Hello everyone, this is Sabita Sunkara. Welcome back to the Enterprise Data Engineer interview series. In the previous episode, we discussed data lineage and data governance. Today we are going one step deeper. So the interview question is, what is an enterprise data catalog and how would you design a metadata management strategy for a modern data platform? And a common senior level follow-up is, how would you enable a business user to discover a trusted data set, understands its meaning, identify its owner, checks its quality and lineage, and safely use it? So this is an important question because enterprise organizations may have thousands of tables, hundreds of pipelines, multiple data lakes, warehouses, APIs, and thousands of reports. The problem is no longer simply storing data. The problem is, how do we discover the right data, understand it, trust it, and govern it? So that's where an enterprise data catalog becomes extremely valuable. Now we are in production scenario. Okay, let's take a real world example. Imagine we are working for a large banking organization. The organization has customer data coming from CRM, core banking, ERP, HR systems, APIs, and other applications. So, ADF or another ingestion platform moves that data into the data lake. So, Databricks process the data. Snowflake contains curated data sets. Then Power BI consumes the data for reporting. Now, suppose an executive opens a Power BI dashboard and says monthly customer revenue 125.4 million. That the executive asks, where did this number come from? So this sounds like a simple question, but technically answering it can be very difficult. So we may have hundreds of pipelines and thousands of tables. So without a catalog, an engineer might have to manually search through SQL code, pipeline definitions, notebooks, and reports. So different terms may also have different versions of the same data set. One team might use customer revenue, another might use customer sales, and both may define revenue differently. So that creates confusion and reduces trust in the data. Now consider another scenario. The source system changes a column or a business rule. We need to immediately understand which pipeline use this column, which tables are affected, which downstream data sets are affected, which Power BI reports could be impacted, which business users are affected. This is where the combination of data catalog plus metadata plus lineage plus governance becomes extremely powerful. Then now let's look at where the data catalog fits into the enterprise architecture. So we might have CRM and core banking at the source layer. So ADF and Kafka at the ingestion layer. Then Azure Data Lake as our storage layer. Then Databricks for processing, Snowflake for curated warehouse data, and Power BI for consumption. The important point is, the data catalog does not replace any of these systems. Instead, it creates an intelligence layer about those systems. It collects metadata from them and provides a centralized view. For example, it can understand what database exists, what schemas exist, what tables and columns exist, which pipeline load these tables, what does each business term mean, who owns the data set, is the data confidential, what is the data quality score, when was it last refreshed, which reports consume it, and where did the data originate. These makes the catalog almost like a search engine for enterprise data. But unlike a normal search engine, it provides context, ownership, lineage, governance, and trust. Now, how does this information actually get into the catalog? We use metadata harvesting and integration. So the catalog can connect to the database, data lakes, ETL platforms, warehouses, BI platforms, APIs, files, and other systems. So it scans those systems and collects metadata. For example, from SQL Server, it may collect database, schema, table, column, data type, and relationships. From ADF, it can collect pipeline, activity, dataset, source, target, and dependencies. From Databricks, we can collect tables, notebooks, jobs, schemas, and lineage information. From Power BI, we can discover datasets, reports, dashboards, and consumption relationships. So, metadata is continuously collected from different parts of the platform and brought into the catalog. So, then now let's look at lineage because this is where our 13th and 14th questions connect. So, there are three important perspectives. So, technical lineage, I already mentioned in 13th question. So, technical lineage answers where did this data come from. For example, CRM to ADF pipeline, then ADLS bronze, then Databricks silver, then Databricks gold, then Snowflake, then Power BI. So, this tells our engineering team the physical movement of data. Then the second one is transformation lineage. Now we can ask, how did the data change? Suppose the raw customer orders table contains customer ID, order amount, discount, order status. The transformation might first filter completed orders, then join customer and product information, then calculate net revenue, then aggregate revenue by customer. So finally, the result is stored as a curated customer revenue dataset. The catalog should ideally provide visibility into those relationships. This becomes extremely useful during troubleshooting and impact analysis. Then the third one is business lineage. So business lineage answers a different question. So here, why does this data matter? For example, customer transactions, thereafter customer revenue, then sales KPI, after that executive dashboard, then business decision. So here a business user does not necessarily care which Spark notebook executed the transformation. They care about what does this KPI mean? Where did it come from? Can I trust it? That's why business context is extremely important in an enterprise catalog. So the types of metadata. Now let's discuss the three major categories of metadata. First one is technical metadata. In this describes the structure of the data. For example, database, schema, after the table, then column, then data type, then file format, partition, pipeline, job, dataset, and source connection. For example, customer revenue. Column is revenue, that data type is decimal 18,2. So that's technical metadata. So now we are in second step, that is business metadata. So business metadata explains what the data actually means. For example, customer revenue could have the business definition. So here total recognized revenue generated from completed customer transactions during the reporting period. So it can also include business owner, data steward, business domain, KPI definition, glossary terms, and approved business terminology. This is extremely important because technically identical columns can have completely different business meanings. So then after the third one is operational metadata. So operational metadata tells us how the data behaves. For example, last refresh time, then refresh frequency, thereafter record count, data volume, pipeline status, SLA, data quality score, and usage statistics, like that. For example, customer revenue last refresh at 1:30 am, the SLA 2 am. So quality score is 98%. So that information helps engineers and business users determine whether the data set is operationally healthy and ready to consume. So here let's move into the most important part from a senior data engineer perspective. So a catalog is not valuable just because it contains metadata. We need to make that metadata actionable. So first one is data classification. So first classify data according to sensitivity. For example, public, internal, confidential, restricted or PII. So here, if a dataset contains sensitive customer information, that classification needs to be visible to consumers and connected to the appropriate security policies. Then the second one is ownership. So every important dataset should have clear ownership. So we typically distinguish between data owner, that is accountable for the business meaning and business uses. Then the data steward, that is responsible for definitions, quality and governance. After that, technical owner, so responsible for the technical implementation and platform. So this prevents critical data sets from becoming orphaned assets. Then the third one is access control. So this is security. This is we should follow the principle of least privilege. Depending on the platform, this can include RBAC, row level security, column level security, data masking, encryption and auditing. So for sensitive data, simply knowing that the data set exists is not enough. So access must also be properly controlled. Then the fourth one is data quality. So catalog information should also include data quality. For example, completeness and accuracy, validity, uniqueness, consistency and timeliness. Okay. So if a business user searches for customer revenue and sees a 90% quality score, they have much more confidence in using that data set. Then the fifth one is impact analysis. This is one of the biggest enterprise benefits. Suppose a source system changes customer status. So before deploying the change, we can use lineage to identify. That is affected pipelines, affected tables, affected data sets, affected KPIs, affected reports and potentially affected business users. So instead of discovering the problem after production deployment, we perform impact analysis beforehand. So that is a major difference between a mature enterprise data platform and a collect of independent ETL jobs. Then the real world user experience here. Imagine I'm a business analyst. So I search the catalog for customer revenue. So instead of getting hundreds of random tables, I can find a certified data set. So I can see the business definition, the data owner, the steward, the source system, the lineage, then the data quality score, then the sensitivity classification, the last refresh time, the SLA and the downstream reports. Then now I can confidently select the correct data set. So this is called self-service data discovery. So it reduces dependency on engineering teams and improves productivity across the organization. So in an enterprise environment, several platforms can provide catalog and governance capabilities. For example, Microsoft Preview is commonly used in Microsoft and Azure environments. Then Databricks Unity Catalog provides governance and metadata capabilities across Databricks datasets. Databricks data assets. Then the Snowflake Horizon provides governance capabilities within the Snowflake ecosystem. Organizations may also use enterprise governance platforms such as Collibra, Alation or Apache Atlas. So the important thing in an interview is not to simply list tools. Instead, explain what problem the tool solves and how it integrates into the overall data architecture. So now let's answer this interview question as a senior data engineer. So if the interviewer asks, how would you design an enterprise data catalog and metadata management strategy? I would say, I would design metadata management as a continuous lifecycle rather than a static repository. So first, I would automatically capture technical metadata from source systems, ingestion platforms, data lakes, processing platforms, warehouses, and BI systems. Then next, I would enrich the metadata with business definitions, glossary terms, ownership, classification, quality, information, and operational metrics. Then I would then organize the assets using domains categories, tags, and relationships so that users can easily discover trusted datasets. After that, governance controls would be applied around access, security, privacy, retention, certification, and stewardship. Then I would integrate end-to-end lineage so that users can understand the origin and transformation of data and perform impact analysis before making changes. Finally, I would expose the catalog through search and self-service discovery while continuously monitoring usage, quality, and metadata completeness. So the objective is to create a trusted data ecosystem where engineers and business users can discover the right data, understand its meaning, assess its quality and lineage, and use it confidently. One thing I would emphasize in a senior interview is this. So, I would not treat the data catalog as a one-time documentation exercise. So, that's a common mistake. In a modern data platform, metadata should be continuously synchronized with the actual platform. If a new table is created, the catalog should eventually know about it. Thereafter, if a pipeline changes, lineage should be updated. If ownership changes, the catalog should be reflected. Then, if the data quality deteriorates, then the quality information should be visible. Then, if a data set becomes deprecated, then consumers should know that, right? So, metadata management becomes an ongoing operational capability. Then here you can see, let's quickly connect the previous two episodes, that is data lineage and governance. So we asked, where did the data come from, how was it transformed, who owns it, how is it governed, right? Now here, data catalog and metadata management, we are asking, how do we make all the information discoverable, searchable, and usable across the enterprise? So lineage equal to data journey, governance equal to data control, then catalog equal to data discovery and context. Also metadata, information that describes the data and its environment. Okay, let me leave you with one important statement here. An enterprise data catalog is not simply a database of table names or a documentation tool. So it is an intelligence layer for the data platform that combines technical metadata, business metadata, operational metadata, then lineage, ownership, data quality, classification, and governance to make enterprise data discoverable, understandable, trusted, and usable. So that is the real value of metadata management. That brings us to the end of today's enterprise data catalog and metadata management. In the next episode, we will take this one step further. So we have to discuss monitoring, lineage, governance, and cataloging. But there's another question senior data engineers need to answer. How would you or how do you continuously know whether your data itself is healthy, fresh, accurate, and trustworthy? That's where we will move into that data engineer 15th question is enterprise data observability. Thanks for watching, and I will see you in the next episode of the enterprise data interview series. Thank you.